6.4 homework. Number 7, decide whether the parallelogram is a rhombus, a rectangle, or a square. Well, looking at number 7, the only thing we see distinctively is we have right angles. So we know if a parallelogram has one right angle, then we know all the angles are right angles. So that makes this either a square or a rectangle. Since we cannot figure out the sides, if they are congruent or not, the best we can conclude is it is a rectangle. Number 8. Look close. I'll try to highlight it. That's not really working, so we use blue. This area. What we do see on this diagram is that side is congruent to that side. Well, it tells us it's a parallelogram. So by rule, opposite sides must be congruent. So we have 4 congruent sides. We don't tell, it does not look like they're right angles, and we cannot tell if they're right angles, but if we have 4 congruent sides, the best we can tell about number 8 is it's a rhombus. Number 9, these are rhombuses. So we have to look at this and see, can we figure out what angle 1, 2, 3, and 4 are? Well, one of the rules about rhombuses is it's an angle bisector. The diagonals are angle bisectors. Since both sides, or all the sides, are congruent, we know the triangles they form in the rhombus, and I'll highlight the triangle I'm talking about. We know it's an isosceles triangle, so all the angles, or angle 2 and angle 4, must be congruent. Since we have one angle given, we can draw our triangle again. We know that the top angle, the hypotenuse, is 106, and the other 2 angles we'll just put in as x. We know they're congruent. We know the sum of 3 angles of all the angles of a triangle have to be 180. So angle x plus angle x plus 106 equals 180. Sum like terms make it 2x plus 106 equals 80. So 2x equals, we're going to subtract 106 on each side, so it's going to equal 74. Divide each side by 2 to get x by itself. We're going to get x equals 37. So the measure of angle, of angle 1 is equal to the measure of angle 2, which is equal to the measure of angle 3, which is equal to the measure of angle 4, which is all equal to 37. Okay, number 10. Again, they're all rhombuses. So we know, again, that each side is congruent to each other, so we know that forms an isosceles triangle. So we can say the measure of angle 1 must be equal to 26. Well, if we look at the triangle, if we know the 2 base angles are both 26 degrees, angle 2 is unknown, but we can say 180 equals 26 degrees plus 26 degrees plus the measure of angle 2. So 180 equals, sum like terms, so that'd be 52 plus the measure of angle 2. Subtract 52 from each side. 128 equals the measure of angle 2. By rule, measure of angle 2 is congruent to the measure of angle 3. So if the measure of angle 2 is 128, that must be the measure of angle 3. So to recap, angle 1 is 26 degrees, the measure of angle 2 is 128, and the measure of angle 3 is 128. Number 11. We have one angle of 58 degrees. know right now this is a rhombus. So we know the diagonals create right angles. Okay. So we know the measure of angle 2 is 90. We know that just by definition. We know that we can prove corresponding triangles. So we know the measure of angle 3 is going to be 58. And the reason I know that is because I can prove by the diagonals side angle side, so I can prove 58 degrees is congruent to angle 3. Now what we have to figure out now is angle 4. We can use again side angle side and prove congruency that angle 1 is congruent to angle 4, which is also going to be congruent to these opposite angles. So if we know, let's look at our triangle that we already have drawn. If we know this angle is 90 degrees, and we know that upper angle, that angle 3, is 58 degrees, this spot right here is the unknown. That is the measure of angle 1. And what we've got to do is set that triangle, the sum of those three angles equals 180. So what we're going to do is we're going to erase that. We're going to put 90 plus 58, I'm just going around the horn, plus the measure of angle 1 equals 180. So we're going to sum like terms. 148 plus the measure of angle 1 equals 180. Subtract 148 from each side, so the measure of angle 1 equals 32. If the measure of angle 1 equals 32, it is congruent to measure of angle 4, so the measure of angle 4 is 32 as well. So our answers would be the measure of angle 1 is 32, the measure of angle 2 is 90, the measure of angle 3 is 58, and the measure of angle 4 is 32. Okay. Number 12. It's a rhombus, so we know again the first thing we can tell is angle 1 is a right angle. So let's write that over here. The measure of angle 1 equals 90 degrees. So now we just got to find the measure of angle 2, 3, and 4. Well, by inspection we can see the little triangle. It's not a very good drawing, but we have a 30 degrees, we have a 90 degrees, and we have angle 2. So we can say 30 degrees plus 90 degrees plus the measure of angle 2 equals 180. Well, that'd be 120 plus the measure of angle 2 equals 180 minus 120 on each side. The measure of angle 2 must equal 60. Okay. We can prove congruency. Again, if we look at the triangles, we know all those intersections at the inside of the two diagonals are right angles. We know opposite sides must be congruent. Opposite sides must be congruent of the rectangle. So we have proven side angle side triangles. So by corresponding parts of congruent triangles, we know the measure of angle 3 must be the exact same thing as the measure of angle 2, which is equal to 60 degrees. The measure of angle 4 must be equal to 30 degrees. So measure of angle 1 is 90, the measure of angle 2 is 60, the measure of angle 3 is 60, and the measure of angle 4 is 30. Going to the next one, number 13. Again, by inspection, we can say without a doubt, I'm going to write the measure of our angles. So we can say measure of angle 1 we're looking for, the measure of angle 2 we're looking for, the measure of angle 3, and the measure of angle 4. So by inspection, and by the rules we know, the diagonals intersect perpendicularly, so the measure of angle 4 should be 90 degrees. And in fact, all those are perpendicular. So looking through and proving by congruency, like we could do before, the measure of angle 2 should be congruent to 35 degrees. So measure of angle 1, again by congruency we can prove, must be congruent to angle 3. So we got to find measure of angle 1. Well, we have a small triangle, I'll highlight in yellow. And we know the sum of those three angles has to equal 180, so we know we've got 35 degrees plus 90 degrees plus the measure of angle 1 equals 180. So that'd be 125 plus the measure of angle 1 equals 180. Subtract 125 from each side. The measure of angle 1 must be 65. So if the measure of angle 1 is 65, actually it's 55, the measure of angle 3 must be 55 as well. Number 14 is a rhombus again. We're trying to find angles, measure of angles 1, 2, and 3. By inspection, rhombus's diagonals intersect perpendicularly, so we know the measure of angle 2 is 90 degrees. We also know that rhombuses have a very unique characteristics where they are also angle bisectors. So we know those angles are corresponding. So if the corresponding or the congruent angle to angle 1 is 60, that means the measure of angle 1 should be 60. So that leaves us to find angle 3. Well, if you have a right triangle, which all these triangles are the exact same, all four of them, you have a right angle. You have one angle that you know is 60 degrees. The other angle is unknown. All we have to do is say 60 degrees plus 90 degrees plus our unknown, which in this case is the measure of angle 3, equals 180. So that'd be 150 plus the measure of angle 3 equals 180. So the measure of angle 3 is, subtract 150 to each side, should be 30. So the measure of angle 1 is 60 degrees, the measure of angle 2 is 90, and the measure of angle 3 is 30. Number 15. We have to find in this rhombus the measure of angle 1, the measure of angle 2, the measure of angle 3. By inspection and understanding that rhombuses make right triangles when their diagonals intersect, so the measure of angle 1 must be 90 degrees, the measure of angle 3 must be 90 degrees. So that means we've got to find the measure of angle 2. Again, we can prove on a rhombus all four of these triangles are congruent. So we can say that angle right there is 90 degrees, and we know the angles also, the diagonals bisect the angles. So where angle 2 is, we'll redraw that graph, redraw that triangle. I have an angle 2, I have a right angle, and I have the opposite angle of 35. So we know right now 90 plus 35 plus the measure of angle 2 equals 180. You add those together, you get 125 plus the measure of angle 2 equals 180. Subtract 125 from each side. the measure of angle 2 must be 55 degrees. Number 16. Now they've changed the lengths on us. Here's what we do. Now we're trying to find the lengths, and we know on rhombuses, what do we know about their diagonals? Their diagonals are equal. So MP is in green, LN is in yellow, so we can set those equal to each other. So we can say LN is equal to MP. LN is x, MP is 2x minus 4. Alright, subtract 2x to each side. You're going to get a negative x equals a negative 4. Divide each side or multiply each side by negative 1, it doesn't matter. Just flip the signs. So x equals 4. Okay, and the length of these, of LN, which is equal to MP, is also equal to 4. Because all we got to do to solve for the length is, remember LN is x, so we already solved for it. So number 16, everything's answer is 4. Alright, number 17. Number 17. I just cut and paste this so I wouldn't have to redraw it every time. So everything tells us LN and MP. So LN and MP, they're equal. So on number 17, we just got to set them equal to each other. So 5x minus 8 equals 2x plus 1. So let's subtract 2x to each side. And we're going to get 3x minus 8 equals 1. Add 8 to each side. You get 3x equals 8. Sorry, equals 9. So we get x equals 3. Okay, well that's part of the equation. Now what we got to do is find the length of the sides. Well, the easiest one for us is MP equals 2x plus 1. Plug in the x, would be 2 times 3 plus 1. So that'd be 6 plus 1. So MP, both sides, or both diagonals, equals 7. So x equals 3, and the length of the two sides is 7. Going to 18, same concept. I'm going to go ahead and speed through this a little bit, and we can just set those two equations equal to each other. So we can say 3x plus 1 is equal to 8x minus 4. Again, so you can follow along, we're doing number 18 now. And we're saying that is LN, and that is equal to MP. Okay, since the 8x is bigger, I'm going to subtract 3x to both sides. So I'm going to get 1 equals 8x minus, 1 is going to equal 5x minus 4. We're going to add 4 to each side, so we're going to get 5 equals to 5x. So once we do our math and we divide each side by 5, we're going to get x is equal to 1. So now we just got to solve that and put that in the equation. So MP equaled 8x minus 4. Plug it in, which would equal 8 times 1 minus 4, which is 8 minus 4. So MP, which is still equal to LN based on the rules of the rhombus, is 4. So we got x equals 1, MP equals LN, which equals 4. Going on to number 19 now. Same rhombus, same concept. We can always say LN is equal to MP in this look. The diagonals are congruent. So let's rewrite this equation. 9x minus 14 equal 7x plus 4. I'm going to subtract 7x from each side. So we're going to get 2x minus 14 equals 4. We're going to add 14 to each side. So we're going to get 2x, okay, plus 14 is 18. Divide each side by 2. We're going to get x is equal to 9. Okay, again, we're not done. We solved for the variable, but now we got to solve the equation. So we know ln equals mp, which equals 7x plus 4. So let's plug in our x value of 9. So it's 7 times 9 plus 4. That'd be 63 plus 4, which would be 67. So ln equals mp 67, and our x value is 9. Number 20. Same rhombus, same diagram. We know our diagonals are ln and mp. We know ln must be equal to mp, say congruent. ln is 7x minus 2, and mp is 4x plus 3. First step, get the variables on the same side, so we're going to subtract 4x to each side. We're going to get 3x minus 2 equals 3. We're going to add 2 to each side, so we're going to get 3x equals 5. Divide each side by 3. X equals 5 over 3. Okay, now find our equation, so we can say with confidence ln is congruent to mp, which is equal to 4x plus 3. Our x value is 5 over 3 plus 3. So that's going to be 20 over 3 plus 3. That reduces to 6 2/3. So 6 2/3 plus 3 would simplify to 9 2/3. So ln equals to mp equals to 9 2/3. Determine the most precise name for each quadrilateral. Okay, looking at 21, what we do notice is all 4 sides are congruent. We cannot tell anything about the angles, so the best we can tell is it's a rhombus. 22, we can tell right now not all 4 sides are congruent. We cannot tell anything about the angles, so all we know are the sides. Opposite sides are parallel and opposite sides are congruent, so the best we can call this is a quadrilateral. Number 23, we can tell all 4 sides are congruent. They all have a measure of 7, and all opposite sides are parallel. We can't tell anything about the angles, so the best we can call this one is a rhombus. 24. Okay, let's look at this for a second. All sides are congruent. It says list the quadrilaterals that have been given this property. Choose amongst parallelogram, rhombus, rectangle, and square. Okay, all sides are parallel, or all sides are congruent. Well, only the rhombus and the rectangle have all sides are congruent. I lied. Only the rhombus and the square. 25. Opposite sides are congruent. Well, that'd be all of them. So that'd be the parallelogram, the rhombus, the rectangle, and the square. Change our ink. Opposite sides are parallel. Again, that's all of them. The parallelogram, the rhombus, the rectangle, and the square. Opposite angles are congruent. That'd be all of them. It's part of the definition. Parallel, rhombus, rectangle, and square. All angles are right angles. The only ones we know that for sure is the rectangle and the square. Consecutive angles are supplementary. That's all. So that's the parallelogram, the rhombus, the rectangle, and square. Oh my. The diagonals bisect each other. Okay. The diagonals bisect each other on all of them. Parallelogram, rhombus, rectangles, and squares. Oh my. Alright. 31. Diagonals are congruent. Okay. The diagonals are congruent. That only happens on rectangulars and squares. Diagonals are congruent. Okay. Number 32. Diagonals are right angles. That only happens when all four sides are congruent. So that's either a rhombus or a square. Each diagonal bisects opposite angles. Again, that only happens on a rhombus or a square. (34) Find the valuables of the variables. Find the value of the variables. Okay, find the value of the variables. And then find the lengths of the sides. Well, this is a rhombus, so we know all the sides are congruent. So let's look for some easy ones to figure out first. Okay, well, if all the sides are congruent, those two look like the simplest ones, and those look like the simplest ones to work with. So let's just set the sides equal to each other. So 15 equals 5x. So let's solve for x. Divide each side by 5. So x is equal to 3. Okay. The other one is 15 is equal to 3y. Divide each side by 3. So y is equal to 5. And we already have the length of the side. It's already given to us right here. So the length of all four sides is 15. Okay, we got to find the variables and the sides again. Again, all of these, this is a square, so all the sides are congruent. So let's look for the easiest one to solve. Okay, well, let's just solve some that just have the y values. So I'm going to highlight them to make them green. I'm going to pick y minus 1 and 2y minus 5 and set those equal together. Y minus 1 is equal to 2y minus 5. Subtract y from each side. So we're going to get negative 1 equals y. Positive. Negative 1 equals y minus 5. Now we're going to add 5 to each side. So we're going to get 4 equals y. We'll rewrite that. Y equals 4. Okay, now we got to solve for x. So I got two equations. I'll circle them. Y equals y minus 1 and 2x plus minus 7. So I'll say y minus 1 is equal to 2x minus 7. We'll plug in the value we have for y, which is 4 minus 1 equals 2x minus 7. So that would be 3 equals 2x minus 7. Add 7 to each side. And we get 10 equals 2x. Divide each side by 2. So we get x equals 5. Okay. Now we've got to find the length of the sides. Again, this to me is the easiest one to solve for. So if we plug in y, so length equals y minus 1, which is 4 minus 1, which is 37. It's a quick proof. Complete the flow proof for theorem 6.15. ABCD is a rectangle. That's given. We got to prove the diagonals. Already highlighted them. We got to prove the diagonals congruent. So step A, ABC is a rectangle. Yes, it is. Why is that? Well, it's because it was given to us. Okay, going to step B. ABCD is a parallelogram. Well, that's just the definition of a rectangle. BC is congruent to BC. Mark that on the board. Well, that's just the reflexive property. So I'll write that, reflexive. Alright. Property of congruency. Angles ABC and DCB. Angle ABC and DCB are right angles. Well, that's just the definition of a rectangle again. It states all the angles are right angles. We'll go to E. Opposite sides of a parallelogram are congruent. So, let's look. What are we trying to prove? AB is congruent to DC. So, from side angle side, we were able to prove triangle ABC is congruent to triangle DCB. Angle ACB and DCB are congruent. Well, and that's just saying right angles are congruent. And so AC is congruent to BD because corresponding parts of corresponding triangles are corresponding. Alright? Corresponding parts of congruent triangles are congruent. 39. Find the angle measures and the side lengths of the rhombus at the right. Okay. I have an angle X and I have an angle 2x plus 6, okay? So we can make this thing work. Again, what do we know about the rhombus? We know all the sides are congruent. So let's look for an easy one to solve for. Well, I see segment HK, and we can say it's equal to all of them, so we'll say it's equal to HG. Well, KH has a length of R plus 1, and HG has a length of 2R minus 4. Okay, so what we want to do is we want to subtract R from each side, and we're going to get 1 equals R minus 4. Add 4 to each side, and we're going to get 5 equals R. Okay, it's not so concerned about the variables. We'll need that. What we need to know now is what's the length of KH? Well, KH is equal to R plus 1, which we found out R was 5, so 5 plus 1, so it's equal to 6. So all the sides are equal to each other. So, all the sides are equal to each other. Sorry about that being messy. And all the sides are 6. Okay, so now, if we wanted to solve for B, which we really don't need to now, but if we wanted to, we could say KG is equal to 6, which is equal to b minus 3. Add 3 to each side. So b must be equal to 9. Alright, so we got the sides figured out. Sides are 6. Now let's find the angles. Okay, what do we know about all parallelograms? Well, corresponding or consecutive sides must have a measure of 180. So the measure of angle H plus the measure of angle G. H is this one right here, and G is this one right here. So the measure of angle H is x, and the measure of angle G is 2x plus 6. Well, they have to sum to be 180. So 3x plus 6 equals 180. Subtract 6, so it would be 3x equals 180 minus 6 is 174. Divide it by 3 to get x by itself. X is going to equal 58. Okay, well, luckily for us, that's one of the angles. So angle is 58. Now we have to find the other angle, which is angle G. Well, screwed up a little bit. The measure of angle G, which that happens to also be, the measure of angle G is equal to 2x plus 6. Well, that'd be 2 times 58, which is 116, plus 6, which would be 116 plus 6, which would be 122. So the measure of angle H is equal to the measure of angle J, which would be 58. The measure of angle G, which would be equal to the measure of angle K, would be 122. So we have a rhombuses that have angles of 58 and 122 and sides of 6. And that, I believe, is your homework.